For those I haven't had a chance to meet yet, my name is Tasha Paul. I'm a new resource soil scientist with Idaho NRCS. I work on Sean's team at the Boise State office. So today's talk will be a little bit of a review for all of you who saw Shauna's web soil survey talk last summer, which, by the way, that's available on Teams for you to reference as well. So web soil survey is the main tool for accessing and exploring soils data. It contains the most up-to-date soils data available for public usage. So today we're just going to talk about the basics of navigating the web soil survey platform, how you can pull data out and make custom soil reports, how you can access web soil survey from your work phone or your mobile device, and then some other hopefully useful resources along the way too. As I was putting this talk together, I kept finding more interesting little things I wanted to share with you all. So I think the presentation might be a little bit longer than 30 minutes, but we've blocked out a whole hour. There should be plenty of time for questions at the end. I can't see the chat box very well when I'm presenting, so feel free to drop questions in there, but I will get back to them at the end. So yeah, whether you're brand new to web soil survey or you've used it pretty extensively, I think you'll find some valuable information here. Still a few more people jumping in with us. Okay, so let's get into it. I'm going to turn my camera off and share my screen with you. So hopefully my screen is visible now. So to access web soil survey, it's as easy as Googling web soil survey and clicking that first link that pops up. But I personally like to go to Soils NRCS Idaho. And under the soil data, click NRCS related soil data and sources. So here we have the web soil survey homepage, along with extra tabs across the top of the screen that contain additional links to soils data. So there's the SoilWeb, OSD, or official series descriptions, which I'll reference again later. And then there's Start Web Soil Survey. You would just hit this button here. But before we do that, I want to show you this link. Find what areas of the US have soil data, just for some background information. So this map shows the availability of SSURGO data. SSURGO stands for Soil Survey Geographic, and it's a database that contains soil information that's been collected by the National Cooperative Soil Survey for over a century. So this is the data you're viewing, whether that's in a spatial or tabular form, when you're using the Web Soil Survey platform. So you can see data is available for almost the entire US. The green areas are where soil surveys have been completed and data is available, versus the light green, where soil surveys are in progress, and light gray, where soil surveys haven't been started yet. So you'll notice that the western side of the US has much more of that in progress and still to be surveyed area. So soil survey data available is different in eastern states that have had numerous update projects compared to Idaho, where our soil scientists are still making progress on initial soil survey. So most of the unsurveyed area in the state is federal land here in the mountainous center of Idaho. And there's a national push to have the whole US surveyed by 2026. So we'll see this changing in the near future. So this is a high-level view of the soil data that's available, and then we can open up Web Soil Survey and take a closer look. So the very first step to using Web Soil Survey is to set your AOI, or your area of interest, as is on this tab up here. So you can manually zoom into an area using the plus tool up here in the upper left of the map, and just draw rectangles to zoom in on an area. And then you can use the red AOI rectangle to set your AOI, or you can use the polygon tool if you want to be a little bit more freehand. And then you would just double click to finish drawing that AOI. And then these options under quick navigation can be used to zoom into an area and then set your AOI as I specified before. One thing to remember is that your AOI has to be less than 100,000 acres in size, and the one exception to that is to set an entire soil survey area as your AOI, and these soil survey areas are closely lined up with the state counties. And don't worry, Web Soil Survey will remind you if you draw an AOI that's way too big. You'll get an angry pop-up window. So another way to set an AOI is to import a shapefile or a zipped shapefile. And that's what I'll do today. I have an example area all prepared, so I'll select that file. And hit Set AOI. And now it's indicated by the blue cross marks. And this is just a site I picked completely at random. But also export AOI over here is super useful. If you've drawn an AOI and you know you'll be revisiting it later, it creates a zipped shapefile for you that you can easily just import in next time you're in Web Soil Survey, and you're off to the races. Okay, so we've set our AOI. Let's go to the next tab over, which is Soil Map. So we can see now the AOI is divided into these different areas. These are called map units. And these are the basic unit of a soil map. They're used to organize the soils across the landscape. And each of these soil maps with its own symbol and map unit name is going to differ in some way from all the other map units within that survey area. So the symbols on this map here correspond to the map unit name and the percent of AOI in this map unit legend table over on the left. So map units are composed of soil components. A component is a soil series, and it's the most specific level of classifying a soil. You can think of a soil series as being very similar to like a species of a plant or an animal. Each one's going to have very distinct characteristics that makes it very distinct from the next one. So each of these map units can contain anywhere from 1 to 3 major components, and then some minor components which are not named in the map unit name. So, and these minors usually comprise less than 15% of the total map unit. Okay, and then you'll notice the scale at the top. You can see my cursor. What this is saying is that 1 inch on the map equals 8,380 inches on the landscape. So there's also this pop-up on the bottom here saying that the soil map may not be valid at this scale. You will see this warning quite often, and it is definitely worth paying attention to. So this pop-up says that this AOI was mapped at a scale of 1 to 24,000. And that mapping scale is typical for rangeland survey data. And to put that into numbers that are like more understandable, 24,000 inches is approximately equivalent to 0.4 miles. So 1 inch equals 0.4 miles. That's called order 3 mapping. And the map units are just going to be larger and a bit more generalized across the landscape. The map units are typically more complexes. That means they have 2 to 3 named components represented in each one. The first one named is going to be the dominant one that has the most percent area in that map unit. So you'll notice that within this AOI, most of these map units are complexes and with multiple named components. So it's going to take further investigation to determine which soil you find where if you were standing in one of these map units. And then to compare, a mapping scale of 1 to 12,000 is also often used, but for ag land and private land that has more intense usage. And this is called order 2 mapping. It just results in more detailed soil maps. And at that scale, 1 inch on the map equals about 0.2 miles. So oftentimes those map units are composed of just one named soil, and that's called a consociation. So anyways, what this warning is saying is that at this level, there is a lot of detail on the landscape that is not fully represented in the soil map. So a soil property that's generalized to the whole map unit, or that's generalized at that map unit scale, it might not be fully true, like if you're standing right here on that particular spot. So we can zoom back out to a scale of 1 to 24,000 and just look and see that this is a scale that this map is intended to be used for. It's the scale at which it was made, and these lines were drawn on the map. So a soil map is a very valuable tool for understanding the capabilities, limitations of the soils present. But it's most useful for planning and preparing for on-site investigations and comparing soil properties over these broad areas. So the soil survey data doesn't usually contain really detailed site-specific information. It's just not intended to replace that site-specific detail. And so that's where on-site investigations would come into play. They're useful to just confirm or deny whether a site is suitable or not for a certain conservation practice, because the ratings supplied by Web Soil Survey are not necessarily the end-all be-all. So, it's especially important to verify soil properties that can be influenced by management, properties like pH or salt concentration or bulk density, etc. But definitely, if there are any doubts, reach out to your local soil scientist. At the end of the day, you just want to be confident in the success of any conservation practices that are being implemented. So, okay, I'm not going to spend this whole presentation talking about scale, but it is a really critical part of understanding Web Soil Survey and how it is most useful to you. So, moving on, we can make some adjustments to the map to make it nicer to look at. But you can use the Legend tab tucked away over here on the left of the soil map. And then right-click and click Edit Layer Properties. And here you can make the font larger, you can increase the boundary width. And just make it so nobody has to squint at this map after it's printed off. Okay. And then when you start looking at the soils in your AOI, one thing to pay attention to first are the map unit phases. So a phase of a map unit indicates info about a series that's even more specific. So it narrows in what you can expect to see there. And it's kind of a first clue of understanding your soils data. So a phase follows the series name. So you'd look over here. An example would be like a really steep slope range, or words like stony, saline, wet next to the component name. These are all obstacles that might affect land management. So pay attention to the map unit symbol as well. Sometimes map unit names can be really similar, but if they're different phases, they're also going to have a different map unit symbol that corresponds to it. Okay, so you'll notice all these map unit names are hyperlinks, and if you click them, you get your map unit description. And soil scientists will sometimes refer to these as MUDs. That just stands for map unit description. So I'll look at this Royal Truesdale map unit. It makes up the largest percentage of this AOI. And we can start by looking at the map unit setting at the top. So these are details that apply to the whole map unit. Underneath that is the map unit composition. You'll see that there are 2 major or named soils, and then 15% minor components. And then notice here the similar soils. So each of the components has a distinct range of characteristics that make it its own unique species of soil, right? And you can find this more detailed soil series info in a document called the Official Series Description, or OSD. So if I go back to that previous page, go to OSD, I can search for that soil component and pull up that document. So for example, you'll see the typical pedon for that soil, and this is the pedon from which the series concept was developed. And then down here is your ranging characteristics. So this has the acceptable range for values for things like the horizon depth, texture, color. This is the most detailed official document describing a soil series. And it's really important to have copies of these documents in the field. So definitely print off copies of any soils you expect to counter in your AOI. If a soil falls outside these range of characteristics, it will not be identified as that series. Because if you remember, a series is the most specific level of taxonomy. If it's just outside that criteria, meeting some but not all for that series, it might be in the same family as that soil. And that's just a slightly looser level of classification. So there are just 2 things to emphasize about the concept of similar soils. First, that similar soils means something really specific, right? It's not just a junk drawer category where any oddball soil can fall into. And also importantly, similar soils have the same interpretations for use in management compared to the series that they're similar to. Okay. So moving down into the map unit description, this is where it breaks down each of the named components. So you'll see a snapshot of prominent qualities for this soil, starting with the royal, the setting on the landscape, the typical profile, properties and qualities, and interpretive groups. These are the classifications that are specific to the component level. So this is a good place to compare components and identify which soil you're standing on in a complex, for example. If there are different landforms within a map unit. A different soil will usually be associated with each one. This is because relief, which includes landform, slope, aspect, it's one of the 5 soil forming factors. So different kinds of landscape relief produce different soils. So these two, the Royal and the Truesdale, have very similar landform, slope, shape, parent material. So it's hard to break them apart based on these factors if you were just standing on the soil surface and looking around. But next, look at the typical profile. Okay, they're very similar in the upper part, A, BW, BK. Same down here for Truesdale. But you can see a key difference, and that's the BKQM down here. So soils in this map unit are difficult to differentiate from the surface, but if you were to dig to about 27 inches, you would know pretty quickly which soil you're dealing with in a particular spot. So what is a BKQM horizon? We have a lot of them in southern Idaho. That is a durapan, and that's a horizon that's been either strongly or weakly cemented by silica and calcium carbonates, moving down through the soil profile for thousands of years. So these soil notations for the horizons contain a lot of valuable information, but it is kind of a language of its own. So when pulling soil reports and looking things over, I highly recommend using the field book for describing and sampling soils to reference these concepts. It's sometimes called the Red Book. It's just a really helpful thing to have a physical copy of in a field pack, but you can also just Google this name and a PDF copy will pop up and it's very easily accessible. So you can look at the table of contents over here on the left and go to Profile Head-on Description. So here are your master horizons, the capital letters, and the horizon suffixes, the lowercase letters. And you can see that the K is for calcium carbonate accumulation, the Q for silica accumulation, and the M for continuous cementation. So it's a good idea to learn to recognize certain kinds of horizons that are going to strongly influence soil properties and uses. So a key feature of this Truesdale soil is that it has a durapan around 27 inches. And you can see in the map unit description how the durapans affect certain properties and qualities. The depth to restrictive feature, obviously quite a bit more shallow than the Royal series. And then also notice the available water supply. It's really low, about 3.2 inches. This is the inches of water a soil can supply to plants. So that shallow durapan is really severely limiting how much water will be available in the soil profile for those growing plants. And then the last thing to note down here at the bottom, it lists out your minor components as well. So even within one map unit at a specific location on the land, you could be standing in one of the major or named components, a similar soil, or potentially any of the minor components listed. But then also, soils gradually shift across the landscape. So the closer you are to a map unit line on the map, the more likely a soil is shifting between two different soil series. You know, the map lines make the soils look like they're arranged in these neat and tidy polygons, but that's just not the reality, especially in the in-between and transition zones. it's always a good idea to look at the neighboring map units and be familiar with the components there as well. So if you're working on a project at a localized level, of course, don't assume that the soil is going to look exactly like the typical profile on the map unit description or the OSD. I think this causes confusion for some folks when what they're seeing on the ground doesn't exactly match what's on paper, so to speak. But due to those reasons we just discussed, the range of characteristics, similar soils, etc., there's variation, and soils described on site will more than likely not 100% match the typical profile on those official soils documents. So to print a PDF of just the map and the map unit legend, that's that table on the left, you would click printable version here in the upper right. If you want this map, the legend, and all of the map unit descriptions, that is automatically added to the shopping cart, the next button over. This is where you add data while you're building your full soil report. And in the end, you'll have one document with all the spatial tabular data that you've selected. So after the soil map, go to the Soil Data Explorer to access all the different kinds of soil data available. I also want to point out this Intro to Soils tab, kind of tucked away on the edge over here. It has background information on a bunch of different topics. If you want like a Soils 101 refresh, or can't remember what a land capability classification is, there's a lot of good information stored here. So Web Soil Survey can be more than just soil maps. It's a really great resource for some of your soil questions as well. The next two tabs over, Suitabilities and Limitations for Use and Soil Properties and Qualities, are where you generate ratings with the spatial colorized map. So on this tab, as the name implies, the soil data is used to predict suitabilities and limitations for use for different purposes. And it's organized into all these different tabs. It really doesn't hurt to go through and look and become acquainted with what's available, but this search feature at the top is super helpful. Just click the drop-down arrow and then, so for as an example, in that one map unit description we just looked at earlier, we noticed that prominent DuraPan. And if you're curious how such a feature could affect the installation of a fence, search fence and see what rating options are available. So it looks like we have one match. If you click that rating, it automatically navigates to the rating down below, and then you can click View Rating. All right, so here we have our map, our tabular data with the rating for each map unit, and then the description below offers more background information on that particular rating and describes what each rating is based on and what it specifically indicates. For example, what's the difference between like well-suited versus moderately suited? This just spells it all out. So to put this in our final soils report, we click Add to Shopping Cart. Okay. So the Soil Properties and Qualities tab contains all kinds of measurable soil properties and then some calculated values like erosion factors. So if you feel like there are just so many soil properties and qualities and you cannot keep them straight in your head, first of all, I relate to that. But secondly, these view description buttons are incredibly helpful just to remember what each of these properties means. So I use those a lot. I am going to look at the rating for the T factor. This value indicates the tons per acre per year of soil loss that's considered sustainable. It's used to evaluate resource concerns related to erosion. So each soil in a map unit might have a different T factor value, and there are different ways to pull that data together to represent the whole map unit. And that's called data aggregation. So the default aggregation method over here is dominant condition. This lumps together similar components and gives a value for the condition with the highest percent composition in that map unit. If we click the drop down, we see our other options. Dominant component would give a value based on the dominant soil by percent composition in that map unit. And then minimum or maximum would give the highest or lowest value present within the map unit. So most often we use the dominant condition. It works really well for a lot of purposes, but reasons to change the aggregation method for a rating depend specifically on your purpose for that data or what you're using it for. Ultimately, it's up to you to decide the best way to pull the data. So for example, for an erosion factor, you would want to see the most limiting value present amongst the components in this map unit for each map unit. So you would run minimum or maximum with the lower selected view rating. And yes, this can be confusing. So remember to click the question mark next to advanced options and then aggregation method. And this explains it in great detail. So let's add this to the shopping cart as well. And now we'll look at soil reports. So soil reports are just the tabular report. There's no map included. And it takes up less space in your final custom soils report. So I'm going to run a report for the hydric soil list, all components. Reports often store more detailed info about the soil attribute. So here, each map unit is broken down into all the components, major and minor, and it has their corresponding hydric status. So it's representing the data on the component level instead of the map unit level. If we run the soil physical properties report, this report breaks down the data even a step further. For each map unit, we have information for each major component, but also each horizon of each major component. And then when 3 values are given in the table, this is a low representative value and a high value. It shows a range of possible values for that property. So reports are just really great when more detailed information is needed. And then when you're running a rating, like was in those other 2 tabs up here, that give a single value for a whole map unit, this is what it means to aggregate data to the map unit level for soil maps. The calculation begins with using a relative value for each soil horizon of each component in a map unit. And then a weighted average is taken for the depth specified. And then a value is aggregated among the components that represents the whole map unit based on the method you pick. For example, the dominant condition found in that map unit. One special report I wanted to bring to your attention is the selected soil interpretations under AOI inventory. This one is nifty because you can select multiple interpretations, up to 3, and compile them together in one report. And you'll have side-by-side columns of your data. It contains a whole bunch of Idaho-specific interps in here, a lot related to engineering, forestry, which would be really useful for our friends up north, and then some good ones for soil health as well. So to demonstrate, I'll scroll through and just select a couple. View soil reports. It does take a few seconds to load. So we'll just take a breather for a second. You can sit back and reflect on how much you appreciate Web Soil Survey. But in the end, you end up with this nice side-by-side report, and it has really easy comparison by soil components. And ultimately, it just takes up less space in your final report as well. Okay, there we go. So now we have a report for each of the components, the major components. If you had checked this box over here, it would also include the minor components. Okay, so this condenses multiple reports into one, and we can add this to the shopping cart. Okay, so now we're done compiling info from the Soil Data Explorer. The next tab over in Web Soil Survey is Download Soils Data. And this is used to pull data from Web Soil Survey into ArcGIS, for example, for people who want more flexibility to analyze the data. If anyone is specifically interested in this, you can reach out to someone on the soils team at NRCS. But I want to briefly show the shopping cart now. You'll notice the title here, and you can add a custom subtitle if you'd like to. And then in the table of contents, you can check or uncheck all the ratings and reports you ultimately want to include. And then all you do is hit checkout. Make sure Get Now is selected and hit OK. So then for $0.00, you get your custom soil resource report that just opened in the next tab over. This really nicely formatted with all the items that you selected. So now I want to talk about using Web Soil Survey in the field on your mobile device. It's always important to do your homework ahead of time and prepare and read your soil reports before a site visit. Bring those printouts with you to the field, your soil report with your map unit descriptions and your official series descriptions. But if for whatever reason you're in the field and you want to reference Web Soil Survey, it's really easy to do so from your mobile device if you have cell service. So I'm going to demo this for you from my phone. So I'm going to switch screens really quickly. So the way to access soils data on a cell phone is to use SoilWeb through a browser such as Safari. There is a SoilWeb app that can be downloaded, but it sends you to a browser window anyway, so I just recommend starting here. So open your browser, type SoilWeb, and click that first option at the top. This is through the UC Davis, California Soil Resources Lab website. You can just click OK for that message. So you can pick your location in a couple different ways. You can zoom to your current location by just hitting that crosshairs button in the upper left. And the signal strength of your phone will determine how accurate that feature is. But then you'll see your marker on the map to show your location. You can also hit the menu drop-down in the upper left and zoom to location and search for a location by address, city, state, lat long, etc. So once you're at your location on the screen, I'm just going to use this random spot that's pulled up here. You can click on inside a single map unit for the map unit composition. So I'll click on map unit 6032 in the center there. Click the drop-down arrow for map unit composition, and you see this one has 3 major components and 3 minor components. I have found this really handy if or when I forget to bring OSDs for minor components out in the field. And then I'm out there and I see something that doesn't seem to line up with the major components. This is a good way to check that data. You can click the component name. I'll do the Cairney soil. And then soil profile. It gives you a really neat graphic of the soil and graphs of different soil features to depth. These other tabs for the component have the soil taxonomy, land classification, some soil suitability ratings. So there's some select choices in here, but definitely not the quantity of data that's found in Web Soil Survey. So if we close this, you can link SoilWeb to Web Soil Survey, and it's very easy. When you do, the area on your phone screen will be your area of interest. So just zoom to the level that you need, and then hit link to Web Soil Survey in the upper right corner. And this opens a new tab in Web Soil Survey. You can see that your AOI is set. You're ready to go. All of your tabs are up there on the top for your soil map, Soil Data Explorer, and you have full Web Soil Survey functionality. So you can access, reference your soils data as you need while you're away from your office computer. And it's just a very useful pocket resource since nearly all of us have these little pocket computers now. So now I'm going to switch back to my main screen. Okay, there is one last feature of web soil survey that I want to share with you all. That is archived soil surveys. It's this link that's kind of hidden away up here next to the help button and whatnot. So follow this link and then click Idaho. So each county has a current and archived data. The current link takes you straight to web soil survey, but the archived link takes you to a manuscript of the archived soil survey for that county. This takes a little bit to load, so I think I pulled one up already. Yes. So the reason in particular I find these so helpful is that it just has so much background information on the soils and the landscape in a survey area. If you open the table of contents, you can see general nature of the area. It talks about some of the geology, the development, more details about how the survey was made. And then if you go to general soil map for broad land use planning, it discusses the most prominent soil series in relation to landform with these figures called block diagrams. So if you want to be more familiar with soils in the area where you work, but find the level of detail in web soil survey really overwhelming when it gives you dozens and dozens of new soil components for every report that you make, this is an excellent way to just get context for your soils starting at a really high level. And if you can get acquainted with the top 10 or so most extensive soils that are described right here, it's just going to help you a lot later on when you're digging into your soils reports. So I have personally found this resource very useful and just encourage all of you to look at the archived survey and the general soil map for your county. So just to wrap up this presentation, if you have any questions or ever need help finding data in web soil survey, please feel free to reach out. If I can't find you an answer off the top of my head, I'll dig in and find one for you. There's just a ton of info available in web soil survey, and it can take a lot of time to get familiar with. I am always learning new things about web soil survey. And then also, if you ever find soil survey data that's confusing or not matching up as expected, definitely relay that back as well. The soils team has some projects in the works to keep improving the quality of data in web soil survey, and we definitely like to know about it. And then as a last reminder, other resource soil scientists throughout the state are currently offering more in-depth soils training to all of our NRCS field offices, and we'll go into more detail on using the web soil survey reports, map unit descriptions, official series descriptions in the field, and specifically for your projects. And so that's all I wanted to share with you today. Are there any questions at this time?